Hello, everyone. My name is Ray. I'm your TA for the Chemical Kinetics and Reaction Engineering class. Today, I would like to show you how to use quantum chemistry calculation to get the activation energy and the delta H for a specific reaction. First, we want to log into RCC using VS Code. So let's go ahead and open VS Code. Now, once you have this opened, if you're a Mac user, then you can enter Shift, Command, and P. Or if you're a Windows user, you can enter Shift, Control, and P. We will be able to open up this panel. So in here, we want to enter SSH. Now you want to select the first one, or remote SSH connect to host, and click on this one. If it's your first time logging into RCC, you might not see the SSH host as listed here. So you want to go ahead and add a new SSH host and enter exactly the same midway3.rcc.echicago.edu as what I have here. Now we see a pop-up window asking for the password. Now let's go ahead and enter the password. And we see a second pop-up window. This time, this is for the two-factor login. You can either enter the 6-digit code on Duo app or 1. Approve the login request on the Duo app. Let's wait a few seconds for the system to load. Great. Once we're logged in, we'll be able to see on the left-hand side something like this. And here we can open the folder. By default, we're directed to the home folder, which is home and then your username. But we actually want to go to the project folder, which is project MENG 24400, and then click on OK. Now we're inside the project folder, and there's a few like subfolders. You'll be working inside this computational assignment folder, but for the demonstration purpose, I'll be going to the demo folder. So in order to open the terminal, if you go to the upper right-hand side, you'll see that there's a few icons. You want to click on the second one from the right. So this one. This one will bring up the bottom panel of the IDE. Here you can see that there's a welcome message, and then there's your username, and there's also the folder name. So we're currently under this folder. We want to go to the demo folder, and in order to do that, the command is cd demo. cd means change directory. And if you enter this command and hit enter, you'll see that the folder has changed from MENG 24400 to demo. So now if we enter ls, which stands for list. So list can give you all the files and the folders under this directory. Here we see that we have a few Python files as well as transition state gas like XYZ folder. And then there's the workflow utilities Python file. And then lastly, we also have the run pipeline.sh. So we want to submit this run pipeline.sh. In order to do that, the command is sbatch run pipeline.sh and then followed by the system name. Since RCC is using Slurm, sbatch is the command to submit jobs to the Slurm job queue. For the system name, we want to go ahead and open up this ts_gas_xyz. In this case, the system name is sn2_cl_cl. The first chlorine is the nucleophile and the second chlorine is the leaving group. So we want to go ahead and enter the first part of this XYZ file, which is SN2, the nucleophile, and the leaving group. Once you hit the enter, you'll see these messages. We see that the job has been successfully submitted to the queue. And in order to check the status of the job, you can do sq-u your username. Here, I see that there's no running job. So if there's any running job, it will appear under this row. Since there's nothing here, it means that the job has completed. So let's check it out. Okay, if we enter ls, we see that there's a new directory created. If we go to runs, here we see that there's the two subdirectories. There's the output and there's the system name. So if you go to output, now we see that there's a few files. We can also view them actually on the left-hand side. So if we go back to the left-hand side panel and click on the refresh, then we'll be able to see those updated files and folders. If we can open those two folders up, and then we can see that there's the frequency plots. So in this case, we have the one imaginary frequency. And then in this case, we have the energy profile for the whole reaction. So we successfully located the transition state for the reaction. And then we also have the reaction product. So this means that the job has successfully completed. If we go to the system folder and then go to the output under that, there's also the thermochemistry. So you'll be recording the values in kcal per mole for both EA and delta H for the reaction. In this case, the delta H is 0, and then EA is 9.6. So basically the last two lines, and you'll be able to get a linear fit if you have multiple systems instead of just this one. So that's basically the workflow. In a separate video, I can dive in a bit more into the quantum chemistry calculation side, like how it works and everything. But this is a very basic example of how to run the calculation without adding too many details. Thank you.